Hello boys and girls. Today we will learn Chapter 8, Section 8.3, Scientific Notation, Part A. Before we learn what scientific notation is, let's study a few questions. Here, you have some numbers. Can you read each of them correctly? For A, we have 20,000, and in Cantonese it is 2,000. B, we have 3,000,000. In terms, there are 6 zeros, so this is 3 million. 300萬1個零. C, this is 70 million. 7,000,000. D, this is 500 million. 1億. And finally, we have 1,000 million. And so, in terms, we call it 1 billion. 10億. Question 2. Here, we have some numbers which are less than 1. A, this is 0.00005. And B is 0.0000008. C, it is 0.000000009. D, this is 0.00000000001. We find for all these very small numbers, it is really difficult to read because there are many zeros after the decimal point. Question 3. Here, we have 4 numbers. Can you tell which is the greatest by the very first glance? Okay, of course, here you can find this one with more zero. This is the greatest. The answer is A. For question 4, there are 4 numbers. Can you find very quickly that which is the smallest? Okay, I think it is not difficult. For B, with more decimal places after the decimal points, this is the smallest. So the answer is B. Here, from question 5 to 8, could you also find which number is the greatest or the smallest for each case? For question 5, can you determine which one is the greatest in a few seconds? Okay, I think it is not difficult to find that C and D are not the answer, but A or D should be the greatest. You have to count the number of zero. There are 9 zeros for A. And for B, there are 10 zeros, so B is the greatest. For question 6, which is the smallest? Similarly, you can easily find A and B are not the answer. And for C and B, you have to count the number of decimal points after number of decimal places after the decimal points. For part B, okay, you have 10 places after the decimal points. And for the answer C, you have 11 places after the decimal point. So C is the smallest. And for question 7, in this case, the numbers are expressed in terms of the powers of 10. Okay, for this case, with higher power of 10, that means there are more zeros. So you can just compare for the exponent, the index, which is the greatest. That means the number contains more zeros, so D is the answer. And for question 8, which is the smallest? Similarly, here, try to compare the indices. The index. Here, the more negative index means there are more decimal places after the decimal point, because take 10 to the power of negative 5 as an example. This is 1 over 10 to the power of 5. That means 1 over 100,000. So with more negative index, that means the number is smallest. So the answer is C. After studying a few questions, here we meet some very large or very small numbers. There are some more daily examples for you. Say, we have the radius of the Earth is around 6,000 something km. For this case, this is also equal to 6,371,000 meter. And the second example, the number of stars in our galaxy is up to, okay, here, a very large numbers. And this is 100 billion. Example 3, we have the maize, the pollen grain of maize. The weight of it is about 0.000000015 gram. Very small weight. Now we have the novel coronavirus disease, and the particle of this virus is spherical type, and the diameter of this is about 0.000000012 meters to 16 meters. All these numbers contain many zeros, and they are not easy to read or write. And here we can try to simplify the presentation of this very large or small number by the powers of 10. Let's study how can we do that. A one-up activity here, like the one in your textbook activity 8.5. Can you express the following numbers as the power of 10? Okay, the first one is easy. We have 1 0, so this is 10 to the power of 1. And for 100, there are 2 zeros, so this is 10 squared. And similarly, for 1000, there are 3 zeros, so it is 10 cubed, 10 to the power of 3. And for this one, 10,000, we have 4 zeros. So this is 10 to the power of 4. And similarly, you just count the number of zeros for each of these numbers. You can easily rewrite them in power of 10. This is 10 to the power of 5, and it contains 8 zeros, 10 to the power of 8. And for the last one, we have 12 zeros, so this is 10 to the power of 12. Now, some very large numbers can be expressed and simplified using the powers of 10. Let's take a few simple examples. Part A, 2000. This is 2 times 1000. That means this is 2 times 10 to the power of 3, 10 cubed. And for part B, this is 3 times 100,000. So this is 3 times 10 to the power of 5. Part C, this is 45 times 100,000, or you can write 4.5 times 1 million. So this is 4.5 times 10 to the power of 6. In some other case, the numbers are very small. Can you also express this number as the powers of 10? Let's take a few examples. Here for the first one, 0.1. This is in terms of fractions, 1 over 10. That means 1 over 10 to the power of 1. And by a to the power of negative n equal 1 over a to the power n, then we can rewrite this as 10 to the power of negative 1. And similarly, for 0.01, this is equal to 1 over 100 equal 1 over 10 squared. So this is 10 to the power of negative 2. And similarly, we can just fill the table. And for this case, there are 6 zeros in the denominator, and this is 1 over 10 to the power of 6. This is 10 to the power of negative 6. And for the last one, we just count. There are 9 decimal places after the decimal point. So this is 1 over 1,000 million. That means it is equal to 1 over 10 to the power of 9, and which is equal to 10 to the power of negative 9. So from the powers of 10, we can express some very small number. Let's study 3 more simple examples. For the first one, there are 3 decimal places after the decimal points. So this is 6 over 1,000. That means 6 over 10 cubes. So this is equal to 6 times 1 over 10 cubes. This is equal to 6 times 10 to the power of negative 3. Part E. There are 5 decimal places after the decimal points. So this is 7 over 100,000. And this is 7 over 10 to the power of 5. That means 7 times 1 over 10 to the power of 5. Then you can rewrite this number as 7 times 10 to the power of negative 5. For F, similarly, here, there are 9 decimal places after the decimal point. So this is 54 over 1 billion. And this is equal to 5.4 over 100 million. And this is 5.4 times 1 over 10 to the power of 8. So you can rewrite this number as 5.4 times 10 to the power of negative 8. We say the above numbers, such as 3 times 10 to the power of 5, 5.4 times 10 to the power of negative 8, they are written in scientific notations. After studying a few questions and examples, now let's learn what scientific notation is. When a positive number x is in scientific notation, then it is written in the form of a times 10 to the power of n. Here, a is a value greater than or equal to 1 and less than 10, and n is an integer. That means n can be positive or negative integers. Actually, a negative number can also be expressed in scientific notations. Say, for this one, negative 32.7, we just copy the negative side. And then for 32.7, this is 3.27 times 10 to the power of 1. So negative 32.7 equal to negative 3.27 times 10 to the power of 1. Now, example 1. Which of the following numbers are correctly expressed in scientific notation? I give you a few seconds to find the answers, which are expressed in scientific notation and which are not, and can you state the reason? Here, A, D, and E, all these are expressed in scientific notations. For B, it is not, because here, this number is greater than 10. It is not okay. For part C, this number is less than 1, so this is not in scientific notation. For part F, this is greater than 10, so it is also not expressed in scientific notation. Actually, there is a quicker way to express the number in scientific notations. Let's take 2 examples. First, we have the case 1, when the number is greater than 10. Here we have 5,000. If we want to express it in scientific notation, first we try to locate the decimal point. And we have to move the decimal point 3 places to the left. So the answer is 5 times 10 to the power of 3. And case 2, when the number lies between 0 to 1, here we have 0.00063. And for this case, the decimal point is moved 4 places to the right. So the answer is 6.3 times 10 to the power of negative 4. These 2 are the number expressed in scientific notations. So here we have a summary. When we move the decimal points to the left, then we obtain positive index or exponent. And this is case 1, when the number is greater than 10. And when we have the number line between 0 to 1, then the decimal point has to be moved to the right. So we have negative exponent. Now let's try to use the quicker way to express the numbers in scientific notations. Take the previous example. Here, the decimal point is moved 5 places to the left. So this is 3 times 10 to the power 5. And for E, the decimal point is moved 5 places to the right. So this is 7 times 10 to the power of negative 5. And actually, the negative numbers can also be expressed in scientific notations. Just copy the negative side. And for the first one, we have the decimal points moved 5 places to the left. So this is 6.1 times 10 to the power 5. And for this one, we try to move the decimal points 3 places to the right until we have the most significant figure 2. So this is 2.19 times 10 to the power of -3. Example 2. Can you express the numbers here in scientific notation? Similarly, do some rough work. The decimal point is moved X places to the left until we have the most significant figure 8. So this is x.39 times 10 to the power of 8. And for part B, the decimal point is moved 1, 2, 3, 4, 5. 5 places to the right. So this is 7.2 times 10 to the power of -5. Now we try the reverse process. You are given some numbers expressed in scientific notations, and can you express them as integers and or decimals? Let's do some rough work. For part A, okay, you have 2.74, and it is times 10 to the power of 4. That means the decimal place is moved 4 places to the right. So the answer is 27400. And for part B, this is 6.1 and times 10 to the power of -7. That means the decimal point is moved 1, 2, 3, 4, 5, 6, 7. 7 decimal places to the left. So this is 0.000000061. Example 4. Here you have to express the numbers in scientific notation. For A and B, they are not in scientific notation because the number 421 is greater than 10, and for 0.00038, it is less than 1. So it is not the correct form of scientific notations. For part A, we just copy the negative sign first. And then for 421, you will write as 4.21 times 10 squared. And then still times 10 to the power of 5. And then here, for this one, by using the law of index, same base multiply together, and then we have a to the power of m plus n. So this is 10 to the power of 2 plus 5. And finally, we have the answer, -4.21 times 10 to the power of 7. And finally, similarly, we try to rewrite this in scientific notation. This is 1, 2, 3, 4. So this is 3.8 times 10 to the power of -4. And it is multiplied by 10 to the power of -2. Similarly, by using the law of index, we have 10 to the power of -4 plus -2. So finally, the answer is 3.8 times 10 to the power of -6. Now, we learned the meaning and some basic conversions of the numbers in scientific notation. Please finish the exercise and assignment in lesson 8.3a.